Hey there, everybody. How you doing? This is Brad Dyke saying hi. I'm talking today with you about a first stage plan of transferring and rebuilding all of this and getting this all into existence, but in a different format. Now, what do I really mean by that? Well, let me explain. Okay, everybody. Yep, I'm getting ready to redo all the labs again, and this time we're going even more quasi multi-hybriding in our approach to start working with technologies that are not there, kind of exist under the water, that allow what's called macro micro clustering technologies to start to develop. Now, as you guys know, I've sent out a couple of requests out to the community to say, guys, we need a better clustering software in Linux. Because frankly, in a nutshell, if it's got a compute value with resources, that means CPU, RAM, and storage, and other resources, by the way, such as input, output, integration, sensory development, and or interactions. That could be a whole god-awful huge list of things, including your own home sensors. But if you have those compute resources and they exist out there, why can't we build an environment where we have what's called high processing power, middle processing power, not necessarily micro power, but small power, such as reduced format here, and then micro power. So what's the value there, right? Well, in a nutshell, microservices go back to about 2002, I'd say. Because back in 2002, there was a terminology referred as VM, but it wasn't the virtual computer or basically remote desktop protocol standings that we know today, but they were called virtual machines. And if you know anything about back in 2002, you would remember that virtual machines didn't have compute. They just had a service, a web service, a load balance service, a node service, basic functional application functionality and driven at the software level only. And we were experimenting with that, and it was really cool because the neat thing about that technology was that we could slap anything in there. May they be small micronodes for like an autonomous network switch, or it was a stack of compact servers, or there was this new thing called the blade server. And I think that's where things broke for VMs, because the industries realized that VMs don't make money for them. Selling hardware does. So what they did is they kind of bastardized it. Now EMC came into existence, Dell became more prevalent. Technologies such as RLX technology, which no longer exists anyway, but you do know them because of the HP Control the HP Control Tower software suite came from the RLX technology way back in the day. And I know because I owned and operated RLX Blade servers. And the cool thing about the Blade servers is they scaled up into usage through the software. But unfortunately, the industry hijacked the technology and contorted it to a profitable hardware kind of mindset. In other words, they could manufacture something in bulk that they could sell along with a software suite. Now, back in the day, we had what's called SPLA licensing agreements, which basically meant that we would set up a cluster, and then the usage of the workload that hit the cluster would be reported to both the vendor who supports it and the customer. And the blades would turn on and off as they're needed. In other words, the resources would come into the pool and go out of the pool as needed. This is where it got hijacked. They broke that entire process apart. They put it out in three different directions, and they never let them come together because they realized there's no profit there. Not for them. There's a hell of a lot of profit for us, the users. But that's not what they want. They don't want to be able to have an industry standard. They want to be able to make things, build up their industries, and so on and so on. Well, now here we're at full circle. EMC is bankrupt, gone, history, bought by Dell. And RLX was bought out, dismantled, taken apart, and gotten rid of. And HP got what it wanted. And it eventually did bring the blade technologies from RLX in a rebranded strategy into the environment. So if anyone has ever worked with RLX technologies, they would know that the HP ProLite blade systems were basically ripoffs from the original company. But they bought them, so it's legitimate. And there's no real complaint about it because they missed the whole point of the adaptive nature of what RLX was thinking. And I was really on board with that technology. But, money won out. The company just wanted to be sold, and they got sold, and they were gone. And that was so unfortunate. But beyond that point, the key thing is now we're back here to almost 20 plus years later. And I asked the same question again. Why can we not get that cluster operating environment done? If you're using TCP as your communication protocol and you have a node representation, in other words, you have some type of running kernel, then you should do this. You can be that. I don't care if it's OSI. I don't care if it's Linux kernel, Microsoft kernel. It doesn't matter. As long as you've got something running an operating system that allows you basic input-output functionality. And then of course, that particular style of technology, the types of processors and what type of algorithms can be assigned to them can be handled, right? This includes, believe it or not, GPUs. Yeah. I kid you not. GPUs, absolutely. I mean, look at them. They're basically computers all by themselves. That's why we use them the way we do for crypto mining. Their functionality is technically independent of the board. So that's what I'm saying. I mean, today, if you go into Proxmox and you want to build a cluster environment, you really have to do quite a few steps to get GPUs into the equation. But once you do get them in the equation, and it starts to work. Now, the problem with this at the cluster level is the assignment of workload. I mean, we know that this guy is great, but only when you got like 10 of them, right? And the secret sauce about Raspberry Pis and devices like them is the miniaturization, which means mathematically the reduced format of the PCB board and the integration functionality is much more functional and faster than that of a motherboard or a larger base chassis like a quad or something like that. Because you have distance, and yes, I know people say that doesn't really add up. Yes, it does. Because when you look at the nanosecond processes versus the microsecond processes, you now can start to interact more effectively at that level versus microseconds to seconds, which is legacy. So, we go from the millisecond level functionality to the microsecond, and then that into the sub-microsecond processes of the processor and state and so on. But a true motherboard, as what we call basically a single CPU motherboard, is much larger, has many more pathways that it has to navigate in comparison to such a small footprint. So hence the terminology, you'll see millisecond communications and discussions and performances versus something that's much smaller, which can go between microsecond to millisecond. You won't find that very often except into the more adept logging processes that can actually show you those recursive time periods. Now, with that, of course, Pis have their limitations because they're small, the processors are smaller, and those are real. But, dude, 5 of these can handle all of your web services. And they're just services. That's all they do. They just handle a simple website. And you can also do it what's called a read-only memory or module. This is a cheat code, by the way. What do I mean by that? Let me show you. So what you do, believe it or not, this has saved my hide in a lot. You take a DVD burner, right? A DVD. And you put a ROM in it. That means read-only DVD. And when you put that in there, it has everything you want for your website. And then this guy becomes the home or the repository, usually associated by a pathway that the website services will say, hey, my directory drive, blah, 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 is this directory drive, and that's my site. And the hackers go after the site, and they try to hack. Why can't they change that website? Why can't they break it? And the reason why they can't break it is, one, it's a specified path. In other words, it's at the command level. And 2, it's read-only. There's no way to change it. You can't rewrite anything. It's just little tricks like that help protect your environment. But back on focus, when you have something like this, like 5 or 10 of these set up in a load balancing acceleration model, that means it will add more nodes as you need them. until it runs out of nodes. And when it doesn't need them, it will get rid of them and put them back on standby, which means they run on a very low voltage load and they don't do much and they don't use up a lot of power. Now, then your bigger boxes can come in and do other things, such as numerical calculation, such as, for instance, extended calculation, such as Minecraft, cryptocurrency kind of stuff. The GPLOS style strategies that are out there. And then, of course, you've got your heavy hitters, and you've got your dual cluster quads that run the database models that can take a lot of workload or not so much workload. And when you realize that you have that kind of scalability, then your workloads can be proportionalized, right? You can set them up functionally, and that they can do all those functions, but more of service-oriented functions. So, for instance, if I want all the microservices to only run to tier 1, which is microservice clustering nodes, then that's all they do. They always stay there. They'll go up and they'll eat up all these resources. They won't touch your heavy hitters. They won't power up your big machines. They just do what you need at the micro level. But the next level, but the extended services, the APIs, the applications, and so on. Those are where your dual processor stacks with multi-cores come into the game, and they'll spin up 2, 3, 4, 5 as whatever you need them to do, and that they'll be out there hitting out. And then your math calculations, your geocrypting, your functional breakdowns, and so on, those are going to be on the big boxes below as you need them. And you can pair them. You can use medium to high, or high and then go after medium. What's ever left over, come back over and help me on this thread. But by giving the cluster the control of the ownership of the data, not the nodes, then at that point stage only can this be very successful. And that means, in a nutshell, to make this cluster software OS system work correctly, the master node controller, in other words, the 1 or 2 boxes that are dedicated to keeping your cluster in a good shape, will own all the resources. And that is technically also the vulnerability. So for all the nodes in use, they would all be in a read-only configuration state, but the master node, the primary and the backup, will be focused on strictly handling and maintaining the disk I/O that's going to be required to maintain all of your data. And there is a little bit of a challenge there. But, ZFS has done a lot, and a couple of other standing protocols for storage and I/O have done quite some substantial improvements that have nothing to do with clustering. And so that means today's protocols could probably handle that I/O workload. And at that point stage, then you've got some overall functionality. The only way that environment becomes at risk is if any of your back-end resources, that means your network storage, your network management, your controlled infrastructure, if any of it has exposure to the internet, you're at risk. But if you have completely segmented, completely away from everything, except the back-end node IP addresses of your nodes, then you've got a very secure environment, because all your nodes are read-only. That's the secret sauce. The data repositories are not, but the nodes are. And all they have to do is reset, and they're back into the game again if they have a problem. And you need to monitor your resets, because sometimes, processors go bad, right? But with that being said, you have the ability of being able to create quite a cohesive cluster model environment. There are some other things involved in that. If you want to talk more about it, please feel free to just go in the comments and put a blurb or two down there, and I can give you some feedback on that. The sad thing is, this is 2.0. 1.0 got hijacked and railed, and I can't lie to you. EMC made billions of dollars. We're talking 30, 40 billion dollars before they finally figured out that everybody figured them out and what they had done, and they said, we're getting out of the water. We quit. And they did. And Dell bought the resources and so on. But it was a really cool tactic and very profitable for them. But the people who paid the price was the industry. We paid way too much for way too little, in my opinion. I know that I'm an EMC certified architect. I've also worked with other environments such as NetApp. NetApp had a much better approach, in my opinion, much more cohesive with the overall ability of sharing the wealth. Let me put it that way. They were never about making a certain amount of profit like EMC did when EMC bought Data General and undercut the NAS industry by making it go out 6 years. It was brilliant strategy on where they brought the Navisphere environments and the Clarions into the equation and undermined everything out there. I was really surprised. And I just wanted my Clarions because they were actually originally Data General NASs before they got bought. So with that being said, I'm hoping that goes away, that kind of activity, because it really did almost destroy a lot of companies, including EMC. It's just, kind of indirectly lying in a way, because, they made things out like they were and they really weren't, and hit a pile of money. And as soon as they realized that people were onto them, they quit. So that kind of gives you an idea that there was definitely conspiracy for this. But that was 10 years ago, so I can't complain about it. But I would like to see that cluster operating environment come back. And I have to honestly say I was really surprised to see how effectively they decommissioned everything in regards and locked the rest of it under NDA, which I believe now is no longer valid because the NDAs only lasted so many years. But with that being said, it doesn't matter because there's enough change this today in our industry to say, hey guys, just forget it, start over, and we'll just make a clean version. And this time it's pure open source, and we can get this to finally get every form of compute power added into, from an x86 base all the way up to ARMs and GPUs and so on, into a common platform that can take advantage of the GPUs versus the Intel processors versus the AMD processor, and you really get into the micro mechanisms of these processors, which is both something I suspect that the Intel company and the AMD companies and the video graphics companies say, I don't know if I want you guys doing that, because you could technically reinvent all of our old hardware and we might not be able to sell anymore. But no, you shouldn't think that way. It's the innovativeness that's given all of these companies their income. What they need to do is leave us alone so that we can continue to tinker and make things work more effectively without such terrible waste. And profitability wise, some of us gauge profitability by the success of all of us. Others gain profitability by their paychecks. Well, I'm not for the paycheck. Been here, done this for 35 years to help everybody out. And I think this is an evolutionary functionality that will automatically kick back to these other vendors and say, wow, what new business we can do. Absolutely. That's the right approach. And then everybody is winning in the situation, not them or us. It's okay. You could actually have a situation where most people come out beneficially from a combined thought and strategy process. The key thing is to not try to, make stupid amounts of money by faking it, lying, and slowing everything down, stifling innovation, stifling technology, stifling the human mind. That just sucks, Well, with that being said, I'm going to be redesigning this. So in the background, as you can see here, this will be broken down. I'm going to be adding some components to it. I don't have much capital right now, and I'm taking care of family members and so on, but I can do a lot with pretty much nothing except some tape and some screws and some, elbow grease. Yeah. But anyways, the goal is to keep reinventing the nature of what we have and how we can make all of this stuff that was once not really usable because somebody upstairs says you need to buy new, because just to buy new, because that's what we need you to do, is to buy new so they can stay in business. Or we can be more practical in our nature and really build things the right way and take advantage of everything out there, including things that are new as well as things that are old. Well, listen, this is Brad Dyke signing off. God bless, and I hope you guys you have a great time and have a great week. You take care.